Hey guys, this video is for section 9E. We're working on pages 15 and 16 in the note packets. Alright, so we're going to revisit these tree diagrams and check out how a tree diagram can be used for determining probabilities. So in the previous section we talked about independent and dependent events happening in sequence, and if either way you just follow a multiplication rule. Well, if you make a probability tree, you can not only illustrate all the outcomes, but you can illustrate their probabilities as well. So it's a useful way to organize if the outcomes are not too numerous, as it says, because you really wouldn't want to draw a tree that takes up a giant sheet of paper. So if we look at the first example that's modeled here, we have two people firing at a target. So if Lee fires, she's either going to hit or miss. And then she does that with a 3/4 or 1/4 probability. Notice that when you put these pair of probabilities on branches, they're typically considered, well, sometimes they're complementary, in this case hit and miss, and their probabilities will add up to 1. And then we have Yuka, who's going to fire next, and she will either hit or miss after Lee hits. And if Lee misses and Yuka fires next, she'll either hit or miss. So the outcomes hit, 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 miss, miss, hit, and miss, miss are just read off the branches. Now, notice that these outcomes all have and in it, and in probability and means multiply. So you just take the probabilities that are sitting atop those branches and you multiply them together. And then, if you've done this correctly, you should see that the total is 1, or something has gone wrong. Okay, so once that tree is drawn out, you'll have the ability to get probabilities just by multiplying the numbers on the branches. The entire sample space is represented in the tree, and when you total the probabilities, you'll get 1. Okay, so then I think there's just 4 model problems to work through. I typically take the approach where before I even read the questions, I fill out the tree, the outcomes, and the probabilities. So if we complete the tree here, we're going to put for Navy, Army, and Air Force, we've divided this up into 3 different possibilities. So right now with the 0.22 and the 0.47, we have 0.69. That would leave 0.31 on the final branch for Air Force. In the Navy, if 19% are officers, then 81% are not. In the Army, if 85% are not officers, then 15% are. And in the Air Force, if 21% are officers, then 79% are not. So then, if we squeeze in right here, outcomes, you could be a Navy officer, you could be in the Navy and not be an officer. You could be in the Army and be an officer. You could be in the Army and not be an officer. You can be in the Air Force. We'll use F and an officer, or Air Force and not an officer. And then when we put probabilities down, you're going to just have to multiply the numbers on the branches. So 0.22 times 0.19, I don't have room to squeeze in the answer, but you get the idea. 0.22 times 0.81. On the Army branches, 0.47 times 0.15, 0.47 times 0.85, and on the Air Force branches, 0.31 times 0.21, and 0.31 times 0.79. So those are the outcomes with the probabilities. Okay, now I'll read the questions in Part B. So if I read Part B, what's the chance that I randomly pick somebody out of the armed forces and find that the person's an officer? Okay, so in B1, the probability of officer, well, if we go over to the tree, we will need this branch, and this branch added up. So when we use the different branches of the tree, we're going to add, but when we find the probabilities on the branches, we're going to multiply. So this expands out to the probability that someone's in the Navy and is an officer, or someone's in the Army and an officer, or someone's in the Air Force and is an officer. So we already wrote those down, and now all we have to do is put them here and add them up. Okay, so if I do that, I got 0.1774, just writing the exact answer down. Part 2, not a Navy officer. Okay, so when we see these nots, it's going to be like a complement idea. So if I'm not a Navy officer, I'm going to do 1 minus the probability I am a Navy officer. So I'll just have to do 1 minus the Navy officer branch. And then for part 3, the probability not Army or Air Force officer. Again, when you're asking me a not question, it's typically easier to follow the complement rule and do 1 minus the probability that you are a Navy or an Air Force officer. So it's 1 minus the Navy officer minus the Air Force officer. Okay, so I'm going to get 0.8644 for that. And as we get further into this chapter, I just want to point out that often more than one rule is used at a time, and that's when things can kind of get piled up on you. So you want to make sure you get these foundations worked out so that you're not too challenged by using more than one rule in the same problem. Okay, I think there's 3 more practice problems on the next page. Okay, so all of these, it doesn't say draw a tree, but you should recognize that when you read something that talks about a sequence of options, that a tree is useful. So in a factory, we've got machine A making 40% of bottles and machine B making the rest. Machine A spoils 5% of the bottles and then doesn't spoil 95% of the bottles. Machine B spoils 2% of the bottles and therefore wouldn't spoil 98% of the bottles. Okay, so the outcomes are AS, AS prime, BS, and BS prime. And then the probabilities for each of them are just found by multiplying the probabilities on the branches. Okay, so often before I even see the question, I've got these things worked out for myself, outcomes along with probabilities, so that I can just use what I need to answer the question. So this first branch, again, not even reading the question yet. The first is 0.02. The next branch, 0.38. The next branch, 0.012. Okay, so do check for yourself that you can see that the sum here is 1. All right, now I'll read the question. It says, determine the probability that the next bottle is spoiled. So the probability of spoiled, you can see that I'm going to go and need to grab this branch as well as this branch. So all I have to do is add those up once I realize what the question is asking. So it came from machine A and got spoiled, or it came from machine B and got spoiled. So since I have those worked out on the tree already, I'm just going to show 0.02 plus 0.012 is 0.032. Next problem. A jar has 2 white and 3 red discs. Another jar has 3 white and 1 red. A jar is chosen at random from flipping a coin, and then 1 disc is taken from it. Determine the probability we end up with a red one. Okay, so first I have to pick a jar from a coin flip. So the first thing in the sequence on the tree is the picking out of jar A or jar B. A coin flip is going to tell us which jar to grab. So that means there's a 50-50 chance that we'll get A or B. Once I pick jar A, I'm either going to grab a white or a red disc. Well, jar A has 2 whites and 3 reds, so there's 5 discs in total. 2/5 white, 3/5 red. Jar B, 3 white, 1 red. So it has 4 discs in it, 3/4 white, 1/4 red. So I either pick jar A and get a white one, jar A and get a red one, jar B and get a white one, jar B and get a red one. So again, these are me just before I even focus on the question, there's an outcome and there's a probability. So if we multiply a half times 2/5, we get 2/10. If we multiply a half times 3/5, we get 3/10. A half times 3/4, we get 3/8. And a half times 1/4, we get 1/8. Okay, always the sum will be 1. Okay, let's focus on the question. What's the chance that we end up with a red one? So if we're going to end up with a red one, we'll have come out of jar A and gotten a red one, or jar B and have gotten a red one. So the outcomes that get added up are AR or BR. Okay, so we add up 3/10 plus 1/8. Okay, I'm going to let my calculator do that for me. And I got 0.425. Next problem. So now we have 3 different bags with blue and red marbles in them. A bag's going to be selected from a die that has 3 A faces, 2 B faces, and 1 C face. And then 1 marble is taken out of the bag. Okay, so similar to the previous problem, we have to pick out a bag first from a die roll. So the bag we pick will be bag A, bag B, or bag C. If our die has 3 A faces on it, 2 B's, and a C, we have a 3 in 6 chance that we pick bag A, a 2 in 6 chance that we pick bag B, and a 1 in 6 chance that we pick bag C. Okay, and then I'm either going to pick out a red or a blue disc. Okay, so if we're either going to pick out a red or a blue disc, we got red, blue, red, blue, red, blue. And all we have to do is look at the bag. Bag A has got 3 reds, 2 blues, so this is 3/5, 2/5. Next, it's 4/5, 1/5. And in the final bag, 2/5, 3/5. So remember, outcomes, before you even check on the questions. Bag A, red disc. Bag A, blue disc. Bag B, red disc. Bag B, blue disc. Bag C, red disc. Bag C, blue disc. Probability. Multiply the branches. 3/6 times 3/5 is 9/30. 3/6 times 2/5 is 6/30. Squishing this in a little bit. 2/6 times 4/5, 8/30. 2/6 times 1/5 is 1/30. 1/6 times 2/5, that's 2/30. 1/6 times 3/5, that's 3/30. Okay, again, you should check your tree. You should definitely see that we got 30/30, which is 1. All right, so to answer the questions, what's the chance that we ended up with a blue disc in part A? P blue. Okay, so blue, that means we picked bag A and got a blue, or bag B and got a blue, or bag C and got a blue. So we just add up those branches. Bag A, blue, 6 out of 30. Bag B, blue, 2 out of 30. Bag C, blue, 3 out of 30. That adds up to 11 and 30. Okay, part B. Part B, I'll squeeze that in up here. The chance that we end up with a red marble. Okay, so those are the other outcomes. 9 out of 30 plus 8 out of 30 plus 2 out of 30. And it shouldn't be surprising, since there's only two options, that we either ended up with red or ended up with blue, that we see here 11 and 30, 19 and 30, they ended up being complementary to each other, meaning their probability summed to 1, because there's only two options, that we finish this with either a red marble in our hands or a blue marble in our hands. Okay, that's the end of section 9E.